Are working on enhancing the secret messages project from the YByte Python curriculum available at www.ybyte.in. In the previous video, we saw a generalization of the transpose method where we write, the incoming message, let's say in rows, but we do not read out column wise from, let's say 0, 1, 2, 3. In fact, we read out in a different order as given in this key. For example, if it's 2013, I read out this column first, the column which has a 0, which is column 1 here. Then I read out, let's say, column which has a 1 here in the key, which is column 2, then this column, and then this column, and hence I end up with a more scrambled message. Now the next logical question is, and the one that we are going to look at in this video is, how do I decode this message? Well, it turns out that this is a very interesting exercise. In fact, we do this in two steps. What we do is to first, ask ourselves a question. Yes, we are getting 4 chunks of data here because n was 4. Where did these chunks come from? Right? So I asked myself this question, essentially same as saying that, okay, which column was this? Let's say in the, in the original, let's say, grid. Now I can find this out. Let's say, look at this chunk. Now this chunk must have come from 1 because item number of 0 here in the key is 1. Item number, or say index of the key, is 1. Likewise, this chunk here must have come from 2 because item number of 1 is 2. Notice here, index of 1 is 2 because index 0, 1, 2, and 3. Likewise, this must have come from, let's say, this being 0, 1, 2. So item number of 2 is 0, which means that this would have come from 0. Now, all I'm trying to get at is that I'm going to rearrange these chunks depending on the key here, and I'm going to just unscramble the message to this form, right? Now, this form, if you recognize, is basically as though the columns were read, in the same order, 0, 1, 2, 3. Once this is done, then I know that a regular transpose decoding can be done, which means that I'm just going to write this again as rows and read out as columns. So these are my 2 steps. Now in this case, it just so happens that, my number of, let's say, the length of the chunk is also 4. That's because, it's basically length of message by n, which happens to be 4. Let's see this once again in another example. Let's say my n was 5 and my key was 13204. So what's going to happen here is that I'm going to read out this column first, the column number 3 here. I'm going to read out first. I'm going to read out column 0 next, and so on and so forth. So I end up with a message which is, let's say, like this. Now again, I'm going to decode this in 2 steps. First, I ask myself a question: where did this chunk come from? And that is available to me when I look at the key. For example, this chunk here, which is basically the 0th chunk, tells me it comes from 3 because item number of 0 in this key was 3. So it must have been this column that came in, and so on. So I first go and rearrange these chunks to get me a message which looks like most straightforward, which looks like as though the columns were read out in the order. And once this is achieved, then again I can do a regular transpose decoding, which means I write this in rows, so PNC, Y-O, and so on and so forth, and then I read them out in column. Now this is standard. Basically, notice the length of each chunk is again the length of the message divided by n, right? And there are exactly n chunks, right? So this we have seen before, and this thing follows, right? Now, just to kind of, let's say, quantify this and summarize this, let's look at the steps that we are following in this. Basically, there are 3 steps. Number 1, we compute the key for decoding, but this is not hard. In fact, all we ask ourselves is where, or let's say which column did a particular chunk in the coded message come from, and hence the decoding key is basically e dot key. So e key being, let's say, the encoding key, e key dot index 0, index 1, and until say index n minus 1. Now this is, if you think about it, exactly same as how we handled the generalized swap, exactly same idea. So you can refer to that as well. Next, we unscramble the coded message by moving the chunks around. Now this is interesting. We are moving the entire chunks around so that it becomes as though the columns are read out in order. Now notice here we are creating chunks, for example, first 4, next 4, and so on and so forth. Now this depends on the length of the chunk, which is basically length of message by n. But the point here is we are not reading every 4th or every 5th element. We are reading contiguous chunks, and hence the slicing has to take care of this. And finally, once we are done with this, we just transpose this message with lessened length of message by n, because that is the regular transpose decoding. So these are the 3 steps that we are going to follow. In fact, the code will follow exactly the same logic. So I'm just going to create a new function called decode, say general, transpose general decode. First thing first, of course, I generate my decoding key. Given the key available to me, I just generate the decoding key. I rearrange my message. Now notice here the slicing. I'm going from kk times m to kk plus 1 times m, because these are contiguous chunks that are being moved around, right? So, and the step here is 1. M is in, let's say, length of message by n, because that is the length of each chunk. Once I do all this, I just go and call my transpose again, but notice this time round I'm calling length of s by n, or I could have actually used m is here as well, and then I return a t. So basically I call a function from inside a function and return the value that I get, and that does the job for me. Let's see this in action, because then it becomes more clear. So I come back to my code over here where I'm generating this, let's say, generalized transpose methods. I just first copy this thing so that it's sort of easier for me. I can reuse some piece of this code. So I come in here, I just say, I'm just going to call it, say, transpose general, let's say, say decode. Right now I'm using the key here 2013, n is equal to 4. Doesn't really matter, because we are going to have to generate a new key anyway. So I just call, say, let's say d key is equal to, say, 0 multiplied by n here. So basically a list which is all zeros but of length n. And now I just do updation of this key. So I just go and say, for a for loop here, say for kk in range, let's say n, I just go and say d key, say kk is equal to key dot index kk. Now the idea here is very simple. I'm just finding out the index of, say, 0, index of 1, index of 2, and so on and so forth, because as we saw, that will allow me to say move those chunks around, right? Now at this point, before doing anything else, let's just make sure this d key is working correctly. So I just go and put a print here, which I'll remove later on. So I go and put a print, let's say, d key. Now I'm not going to do any, let's say, I'm just going to remove this return statement, because it's not really complete, obviously. But I go and call this function. Let's say I just call it, let's say, xtgen decode. And I just say, okay, look, this is transpose general decode xtgen, and n of n being n, and the key. So notice this key that I'm sending it in is the encryption key, and I'm going to generate the decryption key inside this. So let's just run this code, see what happens. Notice my encryption key was right here 2013. Now my decryption key is item number of 0, which is index of 0, which is 1. 203 makes sense, because, for example, take 3. So item number of 3 was 3, and that's what is going on. And this basically is because I want to move the chunks back to where they came from, and hence this makes a lot of sense. Now, having done this, next, like I said, I'm going to actually move my chunks around. These chunks are of a length, which is given by, let's say, I've just use new variable here. Again, remember, variable inside functions will be local, so I can use them quite, comfortably. So I just create a new chunk, here. I say length of message. I say message by, let's say, n. Right now, what this will do is that it will tell me the length of each chunk, because that's message by n. And I just have to do, let's say, a bit of movement here. So I say for kk in, now notice I will move my kk from d key, because remember, I want to move my chunks around. So first I want to move, for example, let's say in this case, the chunk number 1. So chunk number 0 to 1. First I move the chunk number 1, because I want to restore it back to 0. Then I move the chunk number 2, restore it back to 1, and so on and so forth, right? So I'm going to run this over d key, and I'm going to say, temp is equal to, let's say, message. Like I said, again, this has to be carefully done. I'm going to be moving entire chunks around in steps of 1, right? So I do kk plus 1 times m and step size of 1, right? I do this, move chunks around, and I'm just going to say, okay, let's say s is equal to s plus temp. Now obviously I have to define s here, so I say s is equal to, say, an empty string. I think I've done that later, so I'm going to, okay, so there's this piece of code here which I'm going to just remove, since I've written that. Yeah, so I'm going to just do this. Now, just for the sake of clarity, let us print the, say, print over here the temp, and it'll make sense, because now we have the d key available. Again, we'll just run this just to understand what's going on. Of course, this is not the final thing, right? But let's just see this happening, right? Notice, now let's see this carefully. My xtgen is this message. Now notice my decode key is 1203, which means I'm going to start with kk of 1 and move this chunk to the beginning. And that's indeed what happened. I took this chunk miho, I moved it, ho6, I moved it to the beginning. That's temp 1. I then went to, I took, let's say, I went to 2, I moved it to number 1, which is this. So eBay was moved here, and so on and so forth, which means that if I were to also, let's say, print, just for the sake of argument, if I were to print, let's say, S, if I do this, let's say, I'm going to get my message completely scrambled, and as though the scrambling has happened, as though my original message was transposed with the regular column order. Now, having done this, I'm just left with the last step. I'm just going to, transpose this message. I use another variable called, let's say, t, and I say transpose, again, I can call this function here, and I say transpose s, which has been, unscrambled with, let's say, int, say, len of s by n. Now, I must put an int over there because otherwise I end up with a float. That won't work correctly. And with this done, I can just say go and return t, right? And I expect this to sort of work. Now remember, I'm returning t over here, uh, and that should be my decoded script, right? So let's see this in action again. I got my s here. If I look at xtgen, it is whatever it is. Xtgen decode is indeed meet me in the lobby at 6 p.m. Now notice how we have done 2 steps and we have got the decoding accomplished. Now here, before I wrap up, important for me to point out that I'm calling a function from inside a function, which means that this return in the transpose comes back to, so I'm calling this transport, let's say, transpose message here, it comes to this function. With the return, it goes back to the function and then executes from here. It returns t, right? So this is quite interesting to understand. Now, of course, I could have also used just one function, transport general, with a key being, say, 0 till n minus 1. Both are same anyway. Yeah. I hope this was clear. And if you find that this way of learning is fun, do look at our website because we have many such activities. Take care. Thank you so much. Bye bye.